The universe is vast, stretching beyond our wildest imaginations. It's filled with galaxies, stars, and planets, each with its own unique story and mysteries. But what are these cosmic giants made of? What is the essence of their existence? The answer lies in something incredibly small: atoms, the tiny wonders that form the foundation of everything. Atoms are the fundamental building blocks of everything we see and even things we can't see. Imagine a Lego set where each piece is crucial to the final structure. Atoms are like those tiny Lego bricks, combining in countless ways to build everything in the universe, from the smallest grain of sand to the largest star. From the air we breathe to the distant stars, atoms are everywhere, forming the very fabric of our reality. Understanding them is key to unlocking the universe's greatest secrets, revealing the intricate dance of matter and energy that shapes our world and beyond. Atoms are incredibly small. Picture an apple. Now imagine holding that apple in your hand and thinking about how you could keep cutting it into smaller and smaller pieces. If you could keep dividing that apple into smaller and smaller pieces, you would eventually reach a point where you couldn't divide it any further. That's the atomic level. At this scale, the apple is no longer an apple but a collection of atoms. Each atom has a nucleus at its center. This nucleus is incredibly dense and makes up most of the atom's mass. The nucleus contains even tinier particles called protons and neutrons. These particles are held together by a powerful force known as the strong nuclear force. Whizzing around the nucleus are electrons. These electrons move so quickly that they create a sort of cloud around the nucleus, defining the atom's size and shape. The way these particles interact determines the properties of different elements, from the lightness of hydrogen to the heaviness of iron. Each element has a unique number of protons, neutrons, and electrons, which gives it distinct characteristics. These interactions govern the chemistry of the cosmos. From the formation of stars to the creation of planets, the behavior of atoms and their particles shapes the universe as we know it. What if every atom in the universe suddenly exploded? It's a mind-boggling scenario with unimaginable consequences. The universe as we know it would cease to exist. Imagine a single star going supernova. Now multiply that explosion by every atom in the universe. The energy released would be unimaginable. Space itself would be ripped apart and the familiar laws of physics might break down completely. It would be the ultimate cosmic catastrophe. In the aftermath of this hypothetical explosion, the universe would be a sea of subatomic particles. Electrons, protons, and neutrons would hurtle through the void. It's impossible to say for sure what might arise from this chaotic soup. Perhaps new forms of matter and energy would emerge, or maybe the universe would simply dissolve into an undifferentiated sea of particles. One thing is certain: the universe would be unimaginably different from the one we know. The familiar structures of galaxies, stars, and planets would be gone. In this new reality, the fundamental forces that govern our universe might behave differently. Gravity, electromagnetism, and the nuclear forces could interact in ways we can't currently predict. The very fabric of space-time might be altered, leading to phenomena beyond our comprehension. The birth of new cosmic entities, or the complete absence of any structure, would redefine our understanding of existence. This scenario, while purely speculative, challenges our perception of the cosmos and reminds us of the delicate balance that sustains the universe as we know it. The explosion of every atom in the universe would not just be a material catastrophe, but also a conceptual one. It would challenge our understanding of space and time. Einstein's theory of relativity tells us that space and time are intertwined. But what happens when the fabric of space-time itself is ripped apart by such an immense explosion? It's a question that pushes the boundaries of our current knowledge. Exploring these extreme scenarios, however, helps us to better grasp the fundamental nature of the universe. The scenario of a universal atomic explosion is, of course, highly unlikely. However, contemplating such events allows us to explore the limits of our understanding. Curiosity is the driving force behind scientific discovery. It compels us to ask big questions and seek answers in the vast expanse of the cosmos. While we may never know for certain what would happen if every atom in the universe exploded, the journey of exploration and discovery is what makes astrophysics so captivating.